Hi, in this video we will do examples for compatibility of dimensions and dimensions of product matrices. Here we have three matrices A, B, C. A is 2 by 3, B is 3 by 2, and C is 2 by 2. Now the question asks if the given products are defined and what is the dimensions of the product matrix. Let us start with AB. So A is 2 by 3, B is 3 by 2. Then you see that two close by entries are the same. 3 is equal to 3. That means that yes, it is defined. And what is the dimension of the product matrix? So the dimension, you pick the first one, the number of rows from the rows of the first one, and number of columns from the number of columns of the second one. So AB is a 2 by 2 matrix. It is defined and it's a 2 by 2 matrix. How about this one? A transpose C transpose B. Wow, we have to find first we have to make sure we know that this guy is defined. But what is this? C is let me write this a little bit in a better way. So we are trying to see if A transpose C is defined. C we know is 2 by 2. A itself is 2 by 3, but we are not multiplying A to C. We are multiplying A transpose to C. When you find the transpose of a matrix, the transpose will have the dimensions. You have to switch, so it will be 3 by 2 times C, which is 2 by 2. Before it wasn't good, but now with transpose, these two are equal. That means that the A transpose C is defined, and that matrix A transpose C is a 3 by 2. 3 comes from the first one, 2 comes from the second one. So this guy here now, A transpose C is 3 by 2. But then we find its transpose, and that makes this guy an interesting guy because now it is transpose and it's 2 by 3. We are supposed to multiply or find the product of this guy with a C. So if I just put C here, so if you B. B itself is what? 3 by 2. So 3 by 2, after finding the transpose, we switch the number of rows and columns. So A transpose C, the whole thing transpose, is going to have 2 rows and 3 columns. B is going to have 3 rows and 2 columns. And you see that these two are equal. That means that the final product is a 2 by 2 matrix. Yes, this means this is defined and it is 2 by 2 again. Very nice. How about BC plus A? We have to go one by one. BC. B itself is what? 3 by 2. And C is 2 by 2. The closer entries are the same, so then it is defined, and BC is going to be a matrix of what? So you just ignore these ones. This is 3 by 2 matrix. So the product part is defined, but A, when you look at A is a 2 by 3 matrix. We want to add these two guys. You see, you can add two matrices only if they have same number of rows, same number of columns, but these two doesn't have. So the product was defined, but the sum is not defined. So the whole expression is not defined. This is not good expression. A times A. So A is 2 by 3 and A is 2 by 3. Well, the number of rows of A is not equal to number of columns, so that means that this fails, not defined. Yes, so A times A is not defined. How about C times C? C is a 2 by 2 matrix and 2 by 2. That means that, well, the number of rows and columns are equal, and the product is going to be a 2 by 2 again matrix. You have to note here in these two examples that to be able to multiply a matrix to itself, the number of rows and columns of that matrix must be equal. We'll get back to this later when we study the powers of matrices. Okay, so this was the example. We did try to see if the product matrix is defined and what would be the dimension of